Hi, in this video, I'll be showing you how to analyze your four-sided structural stick-built system in seismic. This spreadsheet simulates the sealant, the amount of sealant torn, and the amount of sealant not torn to see if the sealant can still hold the glass. This spreadsheet can be used to analyze 3- or 4-sided stick-built walls for sealant torn and seismic drift. You might want to communicate with your engineer before using this spreadsheet to make sure that you understand how the building moves and how each particular light that you're analyzing is moving. You want to know how much is moving in inches using the drift information from the structural general notes. This sheet does not apply with use of sunshade brackets. So if you have sunshade brackets in your Inviso stick-built system, you should contact your engineer to see how you can analyze the glass here. I'll talk about how to use this for 3-sided structural a little later. Basically, the silicone torn on the capture side will not be considered. To begin, the input values are in gray. You'll see I just made these gray values disappear, so you can ignore that. The input values in gray here, we'll review them. First is a drift percentage and a decimal value. You can find this in your structural general notes, but you'll need to look at each individual light and each individual floor to see what the drift percentage is for the light that you're analyzing. The IE importance factor you'll also find in the structural general notes. This can be 1 or 1.25 typically. The wind load is based on the square footage for your light. There is an exception you can use for wind load. So if you're seeing that this is not green and it's red, and this test is not working for you, you can try a different wind load from ASCE 37-14, section 6.2.1. That's a lot of numbers and words, so I will open that file to show you guys. This tells us that after a seismic event, the amount of time after a seismic event, there's going to be a construction period for a certain amount of time, and during that period, we won't experience full design speed wind loads. So we can use a reduction considering that there will be a construction period where the building will not be occupied and the building will be deemed unsafe to be occupied. You can talk with your engineer to see which of these you could use. Typically, I try using the factor for 6 weeks to 1 year. My engineer might tell me that I could use the factor for 1 to 2 years or from 2 to 5 years. It really depends on what your engineer is okay with. But if you don't want to communicate with them and you want to do it quickly, I'd say go with a 0.8 factor. What you do with this is you take your wind speed that's called out in your structural general notes or your specs, and you multiply the wind speed by the factor. So if I'm using 0.8, I multiply 92 by 0.8. And I get 73.6. That obviously reduces the wind pressures, which then I can incorporate in the spreadsheet. This helps me a lot. So if you're having issues, try that, and you can input which factor you're using here so it's documented. If you're not using it, you can select no. Obviously, you'll want to put the modules, so the width of your light and the height of your light, the bond thickness, and the bond width. So the bond thickness, if you didn't know, the bond thickness is the thickness of the sealant that's holding your glass to the frame. Always want to look at it in decimal. So my bond thickness here is 0.25. My bond width is always an average of the bond width at the horizontal side and at the vertical side. We'll take the least dimensions. And I want to take an average of these two. I'll calculate this average really quick. My average is 0.4065 for bond width. My bond thickness, let's see if it's the same horizontally and vertically. It looks to be the same. My bond thickness is 0.25. You also want to input your setting block distance. That's something you should be confirming in your horizontal deflection check. So your setting block distance is the distance of where your setting block sits from the edge. If it's quarter points, it's obviously a quarter of your light width, and if it's eighth points, it's an eighth of your light width. Once you've entered all of these values, this super cool simulation here will rack your light and input the data into this table. This table here calculates the percent of silicone that will not tear. If you have a three-sided structurally sealed light, you want to delete the value on the side that's captured. So if the bottom side is captured, I'm going to delete that and see if I still have enough structural sealant to hold the glass onto the aluminum. That's pretty much it. If your light passes, this will be green, and if it doesn't, this will be highlighted red. Thank you for watching, and please contact the Jumpstart team or email or call your engineer if you have any further questions. I want to show you one last thing before I go. If you scroll over to the right on this page, you will find derivations and lots of information for how this sheet was created. This is where you can also find links to the derivations, to the PDFs, and to other examples from our engineers, and even a four-sided structural stick-built seismic drift test. The video is super cool to watch. I suggest you watch that. And if you wanted to open the PDF that we opened earlier, you just scroll over to the right and click the link that's highlighted in purple at the top. Thank you so much for watching.